Okay, now we have some trig integrals. Okay, so here we have sine cubed x cos 10x dx. So this is the case where we have a sine-cosine integral and one of the exponents is odd. So in this case the exponent of sine is odd. So what we do in that case is we pull off one of the sine x's, reduce this to sine squared, and the one that we pull off we put next to the dx to form our du. So this will be our derivative. So u then is going to be cosine x. So we want everything else to be in terms of cosine. So make this 1 minus cos squared x. Alright, so now we're going to put u equal to cos x, and du is minus sine x dx. Now we're ready to change over to u. So here we have 1 minus u squared, and u to the 10th. And sine x dx is minus du, so I'll put the minus over here and call that, and that'll be minus du. Alright, and just multiply out, and we can use the power rule. Oh, don't forget that minus in front. Alright, so here we have u to the 10th minus u to the 12th du, u to the 11 over 11 minus u to the 13 over 13. And then just substitute back u is cosine x. Okay, let's look at number 9. All right, another trig integral. So here we have tan fourth x secant fourth x dx. Now this is the case where the exponent of secant is even. And in that case we pull off secant squared and put it next to the dx. And this is the derivative of tangent, so that's going to be our du. In that case, u is going to be tangent x, and du secant squared x dx. So we want to change everything else to tangent. Well, we just have to change this to tangent. Tan squared x plus 1 is secant squared x. So this is tan squared x plus 1. All right, so now we're ready to substitute u equal to tangent x. So we have u to the 4th, u squared plus 1 du. And now that's multiplying through, we get u to the 6th plus u to the 4th du. Now do a power rule. And just substitute back u equal to tangent. And that's it. Here's another trig integral, and this time the exponent of secant is not even, but the exponent of tangent is odd. So in that case, we can pull off a secant tan and put it next to the dx. Secant tan is the derivative of secant. So we're pulling off one tangent, that brings it down to tan fourth x, one secant, that brings it down to secant squared x, and then we have secant x tangent x dx. We want to change everything over to secant. Since this is the derivative of secant, we want everything else to be in terms of secant. So tangent squared x is secant squared x minus 1. So here this is secant squared x minus 1 squared. So now we're ready to put to put u equal to secant x, and du is equal to secant x tangent x dx. Okay, so let's do that. So we have here u squared minus 1 squared. And here we have u squared. And this, all this, that's our du. And again, we'll just do the power rule. But here we have to, I need a little more room here. Okay, here we have to first square this out. So let's do that first. So here we have u to the 4th minus 2u squared plus 1 times u squared. Okay, multiplying out, we get u to the 6th minus 2u to the 4th plus u squared. Okay, now we're ready to integrate this. And we have u to the power rule, u to the 7th over 7 minus 2u to the 5th over 5 plus u cubed over 3. And then just substitute u is equal to secant x. Okay, the integral of tan squared x dx can be easily integrated if you just do a trig substitution. Okay, tan squared plus 1 is secant squared, so so tan squared is equal to secant squared x minus 1. And secant squared is exactly the derivative of tangent, so we can integrate this easily. So this is equal to tangent x minus x. Okay, so that was just a trig substitution. All right, number 12, we have another trig integral. Okay, here we have sine to the 4th x dx. So we have an even exponent. So when we have a sine cosine integral where the exponents of sine and cosine are even, we use our half-angle formulas. All right, so here are the half-angle formulas. Sine squared x is equal to 1/2 1 minus cos 2x. And cos squared x is equal to 1/2 1 plus cos 2x. All right, so in this case, we're going to substitute this right-hand side for sine squared, and sine 4th is sine squared squared. So we have 1/2 1 minus cos 2x squared. Okay, so just square this out. So we have a 1/4 coming in front. And we'll square this, and we get 1 minus 2 cos 2x plus cos squared 2x dx. Okay, let's break this up into two integrals. First, the first two terms which we can integrate right away. And the second one which will require another trig substitution. Okay, so the first one, integrate that. Integral of 1 is x. All right, and the derivative of sine 2x is cos 2x times 2. So this is sine 2x. Okay, now here we're going to do the half angle formula again. 2x is on the left side and we'll have 4x on the right. So here, let's just take a look at that quickly. All right, our half angle formula. So this time we're going to use this and we're going to have a 2x here, so that'll give a 4x on the right. The angle on the left is half the angle on the right. So if this is 2x, must be 4x. So let's do another substitution. All right, we'll bring the 1/2 out in front from the half angle formula. So here we'll be left with 1 plus cos 4x. And now this integral we can integrate, so let's do that. All right, here the integral of 1 is x. And the integral of cos 4x, well, the derivative of sine 4x is 4 cos 4x, so this will be 1/4 sine 4x. Okay, and that's it.